Hi there, I'm Sundar Raghavan. I'm a senior database specialist solutions architect with AWS, specializing in relational databases. I'm here today to talk about the best practices you could follow when you upgrade your relational database, Oracle, from a version 11.204 to any other higher version in Amazon RDS for Oracle. Amazon RDS for Oracle is a fully managed commercial database that is easy to set up, operate, and scale. Major version upgrades are usually complex. This is because every major release will come with some new feature that the application is not compatible with. Moreover, in a database application, relational databases happens to be the centerpiece of the whole thing. And when you have a situation like this, when you do a major version upgrade, it should be planned carefully. And that's one of the reasons why in the Amazon RDS world, the upgrade process itself, even though it is automated, it is a user initiated process. Even though I'll be focusing on 11.204 upgrade to a higher version in this video blog, I made it as generic as possible so that you could use it for a future version upgrades as well. So with that, without any further delay, let's dive into this. Here is the list of versions you could migrate to when you upgrade from 11.204. Major version upgrades are not supported for deprecated versions. It is also not supported for downgrades. So the only way to downgrade is to use the backup that was taken before the upgrade. A major version upgrade from 11G to 12C must upgrade to a patch set unit that was released in the same month or later. For example, a major version upgrade from 11.204 v14 to a 12.102 v11 is supported. However, a major version upgrade from 11.204 v14 to 12.102 v9 is not supported. This is because Oracle version 11.204 v14 was released in October 2017 and Oracle version 12.102 v9 was released in July 2017. Let's see some best practices as part of the pre-upgrade. Before you begin upgrade, the first place to start the process is to review the RDS documentation and Oracle's documentation on best practices for upgrade, as things are constantly being updated. If your DB instance uses a custom parameter group, you must specify a new custom parameter group created for the target version when you upgrade. We recommend that you create a new parameter group and configure the parameters as you would in your current custom parameter group. Similarly, you must specify a new options group if you are using a custom options group. You need to ensure that all the database objects are in valid state before you upgrade. If some of them are not, make a note of them by the object type and also so that you can cross-check it once the upgrade is completed. Also, you have to make sure that all the database links are valid and its working state before upgrade so that after the upgrade, either you can make sure and test it and make sure it's working. If not, then you need to fix it before upgrade so that, or at least you can note it down so that you don't have to spend too much of time troubleshooting it later. When you are upgrading to a higher release, it is most likely that Oracle would have added a lot more objects and features. So this means that you might also need to add more resource, including the space. It is a good practice to make sure you have at least 1 to 2 gigabytes of free space in the system and sysdocs table space. We also recommend taking a manual snapshot before upgrade because this would speed up the pre-upgrade snapshot, which I'm going to explain in the next slide. That will speed up the process because the pre-upgrade snapshot at that point would be a delta to this snapshot. Now, the next set of pre-upgrade best practices are, even though the upgrade is automated, it's a manually initiated process. This means that you have the control on when to start it, typically after making sure the applications are down. um, the duration of the upgrade would vary. If all best practices are followed, typically it would take anywhere between 1 to 2 hours. However, testing this in an environment that is similar to your production is the best way to measure it. Having said that, there are a few things you could do, such as removing old audit log data if it is stored in the database itself, or collecting dictionary statistics before upgrade, because that process also is part of the upgrade. And then if you have the updated statistics, then the collection of the stats right after the collection, full collection, it might also speed up the process. Also, it is a good idea to convert dbms underscore jobs to dbms underscore scheduler, as that would be one of the things that Oracle would do as part of the upgrade. This is because when you migrate from 11.204 to all the way to 19C, and in the version 19C, Oracle is deprecating the dbms jobs. So because it's deprecating the dbms jobs, it will convert those into the dbms underscore scheduler. So if you have large number, let's say thousands of dbms jobs, then the conversion will take time. So that will also add up to the time. The other thing you need to consider is the computation and the memory capacity of the database instance itself. They are typically determined by the DB instance class that you chose. The instance class supported for each release is documented in our documentation. And depending on the target version, make sure the instance class that you're on also supports the target version. If not, you may have to migrate to the target instance class before the upgrade. Also, as you move from a 11.204 to a 19C or any other higher version, there may be a need for you to add more capacity, because as new features are added and new versions always require more resource. And based on the resource capacity, you can add more capacity, or you can choose a different instance. And it could be a good practice. Probably it's a good time for you to consider whether you want to increase your reserved instance capacity based on the target instance class that you need for the target version. Now let's see what the actual database upgrade process looks like. From your perspective, the process is straightforward. All you do is that you either issue the modified DB instance CLI, or you change the version number what you want to upgrade to through the console. Once you do that, then the process will initiate, and after a while the database will be upgraded. However, and then during this process, as soon as you choose to apply it immediately, then the status would be changed to upgrading. But behind the scene, there are a bunch of steps it will go through. So we'll quickly see some of those. It does a pre-check, and it will run some of the initial pre-checking and making sure that database is in the right state and all this stuff. And then we take a backup. So this is a pre-upgrade backup, and it will happen only when the backup is enabled. So you enable the backup by setting the number of retention days, backup retention days, to a non-zero value. If it is set to 0, then it means that backups are disabled, so this step won't happen. For example, in a database where you have heavy loads or ETL type workload or data warehouse type database where a customer would have chosen to disable the arclog mode, so then backups won't happen there. So it's highly and strongly recommended to take a manual snapshot before doing the upgrade. And then we shut down the database and we run the upgrade. So this upgrade is the same process as what Oracle recommends to do. It's the same set of scripts and other details. And then we start the database. And once the upgrade is done, then we'll take another backup of the new upgraded database. So this is the post-upgrade backup. And then we'll complete it and set the status to available. So the actual downtime is only during the update. Downtime is the actual upgrade process. So even if the backups are disabled, enabling it just for the duration of the backup should be considered. So also, if you're enabling it or if you're taking a manual snapshot before, and that will reduce the time it takes to take the backup. So manual snapshot or enabling the backup would be a good option just for the duration of the upgrade. Automated backups are retained only for 35 days. by default, it is retained for 7 days. If the pre-backup, before upgrading the backup, whatever the snapshot was taken, if the snapshot is needed for a longer retention, more than 35 days, then manual backup is recommended. So keep in mind, if the backup is used, AWS backup is used to take a backup, then all the backups are by default or manual snapshot or manual backup. So if either the manual or auto snapshot are restored beyond the deprecation deadline, in this case December 31st, let's say, then it would be upgraded first before completing the restore to the latest version. Hence, if the same pre-upgraded version is needed for future reference, it is better to take a logical backup of such database using something like Export Data Pump. Also, when initiating a major version upgrade process, applying immediate would make the database unavailable immediately. So you just have to choose the right time when you want to do this upgrade. Before upgrading the production database to a major version, you must validate your applications against the new version in a pre-production environment. This reversal of the upgrade process also allows you to measure the time it takes to perform the major version upgrade, also any other challenges that you might encounter in the production world. So the process includes something like this. You first create a snapshot of your existing production database using the create DB snapshot CLI call, or you can use a console. Restore the database using a restore DB instance from the DB snapshot, or you can again use a console for this. But keep in mind, when you restore the snapshot, it would create a new database of the same version as that of the production. Then you can use this database for testing. Whether you want to take care of the post refresh procedures or you want to keep it the same, it's up to the business requirement and the security requirements that you have. In some cases, after the refresh, you might want to mask some of the critical data even for testing. So that wouldn't impact the overall process or the estimation. So at this point, you issue a modified DB instance so that you can upgrade it to the higher version and then go through the upgrade process. So then you perform the actual testing on this database. So once you have completed the testing in this one and note down all the changes we have to do, all the process-wise what adjustments you have to make, then you can schedule an actual production upgrade in your production database. So we've talked about a lot more in detail about this process, also several other best practices in the blog that's mentioned in the link here. Also, there are some restrictions when it comes to the major version upgrade. For example, major version upgrades, downgrades are not supported. So the only option is to restore it from a backup if it is enabled. And keep in mind, when you do that, then it will change the endpoint. Also, the other thing that you need to consider is that when you upgrade the major version upgrade, it should match the month when the PSU was released. For example, if a major version upgraded from a 11.204 v14 to a 12.102 v11, then it's okay, it's supported. However, a major version upgrade from a 11.204 v14 to a 12.102 v9 is not supported because the PSU for the 11.204 v14 was released in October of 2017, whereas the 12.102 v9 was released in July of that same year. So these months are different, so the PSUs won't match, so it won't work. The other factor you need to consider from the restriction perspective is that if you have the multi-AZ, the multi-AZ upgrades both the primary, or the RDS will upgrade both the primary and the standby database at the same time. If there are no operating system updates are required. The primary and standby both go through this upgrade simultaneously, which means that database won't be available during that time. However, if operating system updates are required in a multi-AZ environment, RDS chooses a slightly different path. What it does is that it updates the operating system on the standby database instance first and upgrades the standby instance, fails over the primary instance to the standby instance, and then performs a OS upgrade on the old primary or the new standby, and then performs a upgrade of the new standby as well. So as you can see that in a multi-AZ where the OS upgrade is required, then it slightly takes a different path. When you initiate a RDS upgrade process for an RDS instance with read replica, it upgrades a source database first, and during that time, the read replica would be available for you to query. But once it is done, all read replicas are upgraded simultaneously, regardless of the maintenance window. This is because the for the read replica under the hood, we use the data guard, and that requires both the source and the target database to be of the same version. So that's the other reason. If you're using a cross-region read replica, it generates and copies the options group that matches the target group. Keep in mind the options group that you create are within the same region. So if we are having a read replica across the region, that options group has to be created on the target side as well. So now, what if we don't or if we can't afford a downtime for this upgrade? There are a couple of choices. The first one of which is the AWS database migration service. It's a cloud native service that makes it easy to migrate relational database, data warehouse, and NoSQL database, and all other type of data stores. You can use DMS to migrate your database typically, but you could also use it in this case as a tool or mechanism to reduce downtime. So you can create the DMS between your old version and you to the new version. So your new version is going to be all shell database with the new version software, everything, and then DMS will migrate the data and everything. So you go through the same process as what you typically do in terms of the DMS migration. First you do a full load and then do a CDC, and once both source and target are in sync, and then you can cut over, you can point your applications to the new database. The other option is using Oracle Golden Gate. So Oracle Golden Gate can collect and replicate managed transactional data between two databases, right? So if both databases are in the cloud, then they can be the same region or even different region. So for example, you could use this for the upgrade in such a way that you can have an EC2 instance that could be configured as Oracle Golden Gate Hub. And the Hub instance actually has a Oracle Golden Gate software configured with two different Oracle, could be Oracle, two different Oracle Golden Gate homes, for one for the source and one for the target. So that way the Hub instance, it could also be having a database. Then the source could be running 11.204 and the target could be running 19C, then it could replicate. And in fact, you can replicate it in such a way that with two different Golden Gate home, you can do a bidirectional in such a way that you, in case you want to fail over to the new version, you can use it, and after a week or two, then if you find that then the 19C's incompatibility actually changed something and then application is not working the way it's supposed to be, then you can fail back to the older version just in case if you want to do that. So that way you can do this transition as a fallback as well. Sometimes after upgrade, it is possible one or more bug fixes will cause optimizer to select a different runtime query plans for some SQLs or some business critical SQL. If this causes performance problem in a particular application, it is not uncommon to set the optimizer feature enable is a parameter to a previous version or a patch set to effectively to downgrade your optimizer functionality while the problem is being investigated and find a permanent solution. The parameter can be set at the system or session level. To set it at the system level, and you have to modify this parameter from the DB parameter group. And keep in mind that you cannot change the parameter value in the default DB parameter group. So if you are going to customize this value, then you would have to create your own custom parameter group and attach it to the database before we changing it. The parameter can also be set at a specific SQL level using Oracle's hint. Since the client software and the server software run on different machine, they can be of different version. So even after upgrade, you can technically run the client at the same software version. But however, we recommend to keep them the same to get the best value and also avoid any incompatibilities. But also we understand that it's not always possible. There are some times where you might end up running a commercial off-the-shelf application that comes with its own client and it can be changed, and there are many other reasons. So um, in which case we strongly recommend that you test in detail. So your test should be done at different stages from the client perspective, from the database perspective, and all the compatibility and everything. Oracle also has a My Oracle support document where it talks about the all possible combination of the clients and its compatibility and general issues and things like that. So it's also highly recommended to view this document. That's all for now. These are some best practices I thought I would share in this video blog. For more in detail, check out the resources section I mentioned earlier. I hope the best practice points I've discussed in this video blog is useful for you when you upgrade this. Thank you for watching and have a happy cloud computing.